In this video, we are going to talk about writing exponential functions from a given graph, table, and scenario. So if you remember, the general exponential function is written in the form f of x equals a times b to the x, where a represents your starting amount or starting value, which is also your y-intercept on a graph. And b represents your multiplier, what you're multiplying each term by. Another way to refer to b is also as your common ratio. And x, or t, represents the number of times that multiplying is occurring. So there are two different situations of exponential functions. One is growth and the other is decay. Growth is when the number or initial value is being multiplied by a number greater than 1. So when you have a value given as a percentage, you add it to 1 as a decimal. Decay is when a exponential function is decaying or decreasing by a multiplier less than 1. So given a rate, if it's decreasing by 6%, you change 6% to a decimal and subtract it from 1. So let's take a look at a graph. We're given an exponential graph, and it is shown that it is a growth graph since it's increasing from left to right. In order to write an equation from an exponential graph, you need at least 2 points. The first point you want to look for is your y-intercept. If you remember, your y-intercept was your a value. So here we can see our y-intercept is at 1, 0, 1. The next thing you want to look for is another point on your graph. So I can see when x is 1, the y value is 2, 1, 2. That means I'm multiplying my y value by 2. So let's double check that holds true for an x value of 2, a y value of 4. 2, 4 indicates it's also being multiplied by 2. So our equation starts with our y-intercept, f of x equals 1 times our multiplier. We are multiplying our y values by 2, so our multiplier is 2 to the x, and that's our equation of that exponential graph. Lastly, we have tables. Just like we did for the graph, you want to look for the y-intercept or the starting value in a table. Remember, when it's a y-intercept, the x value is 0. So this right here would be our starting amount. We also want to look for what it's multiplying by each time. 3 times what gives us 6? That's times 2. 6 times 2 gives us 12, so our multiplier would be 2. So our equation, f of x equals our starting value of 3 times 2 to the x. Same with this table. We look for our starting value. Remember, it's when x is 0, so it's at the point 0, 2. And we find what our multiplier is. So we're multiplying by 3. So our equation, f of x equals our starting value of 2 times 3 to the x.